Alright, with this question here, we've got someone investing some money into an annuity. So annuities are ones that pay interest to the person's account, to their investment, so it grows basically. So they're investing $80,000, 6.4% per annum, compounding monthly. So that goes up a little bit more than it would if it was going up just annually. Helen expects her investment to be fully exhausted after 15 years. Okay, so actually, sorry, she's invested the money, but she's obviously withdrawing money from it rather than just letting it grow if she's planning on exhausting it. So find the monthly withdrawal that Helen can make. So finance solver, because we've got regular payments as well as interest. So 15 years is 15 times 12, 6.4. PV is a negative 80,000 because it's gone into their account, into the bank's account, because it goes from hers to the investment, well, whatever it's invested in. PMT is going to be unknown, and FV is going to be 0, and that will give us a withdrawal amount of 692.49. So that's how much she can take out if she's going to run it out in 180 payments. Okay, so the answer for part A, 2.4950 per month. Okay, next bit, find the amount that Helen has left in the investment after 2 years. So even though we've just done that sort of calculation to the end, we're going to leave the payment there, but we're just going to now ask for the future value after 2 years of payments. So 2 years of withdrawals, sorry. So 2 times 12, and this time we're going to ask for the future value if this is how much she's withdrawing every time. Okay, so we've got 73,000 left after 2 years. Left in the annuity fund after 2 years. Okay. Part C. Helen continues to withdraw the same amount from the investment each month. So there's been a change of conditions. So it's gone down in interest. So luckily, the part before has asked us to get to whatever the balance was after 2 years already. So that bit's done. And now they're asking if she continues with the same withdrawal, how many more months to the nearest month will her investment last? Okay, so this is where you keep that withdrawal the same. You copy, using Control C, the value of her investment. Now this is invested, so it stays negative. Alright, and we're going to ask this to be 0, because that way it runs out. Change the interest rate to its new one, and now we're going to ask for what the months, how many months there are to the nearest month. Okay, so she can withdraw that amount for basically 153 months, and then a little bit at the end. So to the nearest month is just 153 more months. Now double check the question, because it might ask total amount of months, or it might ask how many more months. How many more months? Okay, so yeah, it's just 153, then we don't have to add it to the previous 24. Okay. Part D. If Helen would like her investment to still be exhausted after 15 years in total, what is the new monthly withdrawal to the nearest cent? So, once again, we're going to have the same starting place. We're going to have 0 as our FV. We're going to keep this, instead of allowing it to run for 153 months, we're going to say it's for 15 years. So remember, it was 15 years minus the 24 that has already occurred. Alright, so that's how much longer is left on the loan. We're going to ask for it to go from 73 grand to nothing, and we're going to put the PMT as the unknown now. So it's told us it's 156 months more. The PMT is the unknown, and that's what she's allowed to withdraw if she wants it to last that long. So if she wants to go for 156 more payments, she's got to reduce her withdrawals slightly. Alright, so just to remind you that that was 15 lots of 12 minus 24, because already 24 months had passed, and that will give you the, okay, and that's how you do